Okay, so here's your assignment, and what I'm going to do is I'm going to go through the odd problems, and that'll leave you with the even ones. Okay, so I'll complete the odd ones, you complete the even ones. Okay, number 1, it says complete each statement about parallelogram KMPR, justify your answer. Okay, well, angle MPR, that's this angle here. Based on our properties, opposite angles are congruent. So opposite of MPR is MKR. So angle MKR. Justification, opposite angles are congruent. Okay, number 3, we have MT is congruent to what? Okay, well, I think it's TR. Because, and here's the justification, diagonals bisect each other. Diagonals bisect each other. Okay, then it says number 5, MP is parallel to what? Well, by the very definition, it should be parallel to the opposite side. So that would be KR. KR. Okay, then we have number 7. We have angle MPK. Angle MPK. And if you'll remember that Z shape from the alternate interior angle. So if it's MPK, then the alternate interior to that would be RKP. Angle RKP. And the justification is alternate interior angles are congruent. And the reason why we have alternate interior angles is because we do know that a parallelogram has a pair of parallel sides. Okay, number 9, angle MKR plus angle PRK. So MKR and PRK. Well, those are adjacent angles. And one of the things that we had on our angles was that they are supplementary. So they add up to 180 degrees. Okay, so adjacent angles were supplementary. Okay, number 11. Find the values of X, Y, and Z in each parallelogram. Okay, well, first thing that I noticed was right here. That's a right angle. And since it's a parallelogram, I know that these angles are parallel, or excuse me, those lines are parallel, and these lines are parallel. That makes a Z shape with X. So that makes X 90 degrees. Okay? I also know that X and Y, or excuse me, actually what I notice next is that this angle is 53 degrees and Z is the opposite angle. Okay, so if Z is the opposite angle, then that means that Z is also 53 degrees. That leaves Y. I could do a lot of different options here. I can take 180 and I can subtract 90 because one of the angle measures is 90 and I get 90 left over, and then because Z is 53, I can subtract 53 and use my triangle sum theorem. And I get 37 degrees. So angle Y is 37 degrees. Okay, there's more than one way to go about it, and there's more than one way to do it. Okay, number 13 asks us to find the values of X and Y in each parallelogram. So they do tell us it is a parallelogram. Since we're working with the sides, that means I know that the two opposite sides are congruent. So that makes 2x equal to y, and that makes x equal to 2y minus 9. Well, I have two different equations, and I have two variables in there. Well, what I notice is that the y equals 2x, which means I can use substitution. That means I can replace y in the other equation with 2x. So I get x equals 2, and now I'm going to replace y with 2x. It's called substitution, minus 9. And I get x is equal to 4x minus 9. I'm going to subtract 4x from both sides. So that gives me a negative 3x equals negative 9. And then we divide by negative 3. And x equals positive 3. So x equals 3. And then we got to find y. Well, I already know y is equal to 2 of the x's. So y equals 2 times 3, which makes y equal 6. So y is equal to 6. JKLM is a parallelogram. Find each measure. Okay, so they want us to find the length of JK. So JK is the 7x side. So I know, because it's a parallelogram, that 7x is going to equal 3x plus 14. And I'm going to solve for x. So I'm going to subtract 3x from both sides, and I get 4x equals 14. And I'm going to divide by 4. And x is going to equal 3.5. Okay, that's what x equals. However, I have to find each angle measure. And that means I have to do 7 times 3.5 to get the actual measurement. And 7 times 3.5 is 24.5. So I know JK is 24.5. Angle L. Angle L is over here. It's equal to 2z minus 3. This is number 17. And 5z minus 6 is my other angle. Now we know from our properties chart that these two are supplementary, meaning they add up to 180. So 2z minus 3 plus 5z minus 6 adds up to equal 180. Combine like terms. I get 7z minus 9 equals 180. I'm going to add 9 to both sides, so 7z equals 189. And then I'm going to divide by 7. And that makes z equal to 27. Now, just like before, I found z, but I didn't answer the question. They asked me to find the measure of angle L. That means I need to substitute that back in. So 2 times 27 minus 3 gives me 54 minus 3, which gives me 51. So angle L is 51 degrees. You find 16 and 18. WXYZ is a parallelogram. Find each measure. So this time we're dealing with the diagonals of a parallelogram. So they want me to find WV. Okay, well, I know the diagonals of a parallelogram bisect each other. That means they split each other in half. So B plus 8 is the same as 5B. So I'm going to subtract B from both sides, and I get 8 equals 4B. And then I'm going to divide by 4, and I get 2 equals B. Now, just like before, I found B, but that's not the question that they're asking. They want me to find WV. WV is B plus 8. So that's going to be 2 plus 8, and that's going to give me 10. Next, they want me to find XZ. XZ is the entire diagonal. So I know 3A minus 7 is equal to 2A. I'm going to subtract 3A from both sides. I get negative 7 is equal to negative A. And I need both of them to be positive. So I'm going to divide both of them by a negative. And that gives me 7 is equal to A. Okay. Now to find the entire length of the diagonal, it's going to be 3a minus 7 plus the 2a. So I'll have 3 times 7 minus 7 plus, then I've got 2 times 7. Okay, that gives me 21 minus 7 plus 14. And that'll give me 14 plus 14, which is 28. So I know XZ has a length of 28. 23. What is the value of X in PQRS? Well, they give me the opposite angles, and based on our property sheet, we know opposite angles are congruent. So 3x plus 25 is equal to 5x minus 5. I'm going to move my 3x over to my 5x, so that gives me 25 equals 5x, If I move the 3x over, that gives me 2x minus 5, and then I'm going to move the negative 5 over, and that gives me 30 is equal to 2x. Divide by 2, and 15 is equal to my x. Since it did ask me to find the value of x, that's going to be A. Okay, the perimeter of triangle CDEF is 54 centimeters. So let me draw a picture. CDEF. It's not to scale. Find the length of FC if DE is 5 centimeters longer than EF. Well, if I make EF X, then this would be 5 centimeters longer, so it would be the X plus 5, which makes FC X plus 5. And it makes CD X because opposite sides are congruent. Now that helps me set up an expression to find the perimeter because I have to add up all 4 sides. So x plus 5 plus x plus 5 equals 54. Combine like terms. So I have 4 x's, and then I have my numbers, plus 10 equals 54. And I'm going to subtract 10 from both sides, so that gives me 4x equals 44. And then I'm going to divide by 4, and that gives me x is equal to 11. Okay, they do have 11 as an answer choice, but that's not what they asked me to find, so I know I can cross that one off. They asked me to find FC. Well, that's x plus 5. So even though x is 11, I needed to add 5 to it, which is h, to find 16. Okay, 27. Let me see if I can blow this up a little bit more. Okay, multiple step, 3 vertices of parallelogram PRTV are at 4, -4. So I'm going to try and plot this. 4, -4. There's P. -10, 0. That's R. And 5, -1. And that's going to be V. And they want us to find coordinate T. Okay, well, here's the thing about parallelograms. They're parallel sides. So this is where slope comes in. Because the sides are parallel, they should have the same slope. So if I find the slope of RT from R to P, then I can recreate that slope from point V to point T. So if I'm starting at -10, then that means I'm going down 4 and to the right 1, 2, 3, 4, 5, 6. Okay, then from point V, I have to go down 4 and to the right 6. If I go down 4, I end up at negative 5. And if I move 6, then I end up at 11. So my coordinate for point T is 11, negative 5. That would help us complete our parallelogram and making sure that the opposite sides are parallel. Okay, this one's a little bit different. It's conditions of a parallelogram, and this time we don't know it's a parallelogram. All we know is it is a quadrilateral and it has certain properties. So if we can prove that these properties are of a parallelogram, then we can prove it is a parallelogram. So if I have number 1 here, I just have a 4-sided figure. I don't know if it's a quadrilateral or parallelogram or not. But based on these markings, these are a pair of opposite congruent angles. And based on these are also a pair of opposite congruent angles. Then I can say yes, this is a parallelogram because opposite angles are congruent, and that's based off of our properties. So yes, this is a parallelogram. For number 3, now you're going to have to go back because you see I see 2 triangles here. Okay? I also see I have a pair of congruent sides and a pair of congruent angles. Well, I also see that they share a side. That makes it reflexive. That means I have congruent triangles. So I have side angles, side, congruent triangles. And since the triangles are congruent, that means all of the parts of the corresponding triangles are congruent. What that means is that I know these 2 sides are congruent, I know that these 2 angles are congruent, and these third angles are congruent. Okay, that sets up for me the fact that yes, this is a parallelogram because I've proven the opposite sides are congruent using triangle congruency. So all that stuff that we've learned so far could have actually applied. Okay. Number 5. I look and see and I have a pair of angles here. Well, they make a Z shape. Those are alternate interior angles. If I look at my single ones, those are also alternate interior angles. Well, we had a property that said if you have alternate interior angles that are congruent, then you have parallel lines. So yes, this is a parallelogram. Because the alternate interior angles are congruent, that means we have our definition. 2 pair of parallel sides. So yes, those are parallelograms. Number 7 show that EFGH is a parallelogram for S equal to 5 and T equal to 6. So what they want us to do is verify that this would be a parallelogram. Since they give us the diagonals, we know from our properties chart that diagonals should bisect each other, meaning that the 2 parts, 2S, should equal the other part, S plus 5. And since they've given us S, we just need to confirm whether or not it's congruent. So 2 times 5 should equal 5 plus 5. And we do get that 10 does equal to 10. So based on S, this part is a parallelogram. Okay, so now we need to confirm it with T, which is the other diagonal, because they both have to bisect each other. I get T plus 12 should equal 3T. Well, T is 6, so I should have 6 plus 12, and 3 times 6. I get 18 and 18. Well, that confirms and checks out. So by evaluating these expressions based on what we know about parallelograms and that the diagonals should bisect each other, these check out. So the work is showing that these work. Okay, number 9. Show that BCGH is a parallelogram for x equal to 3.2 and y equals to 7. Okay, so here we have sides, and we know that based on our parallelogram properties that the opposite sides are congruent. So that means 6y minus 14 should equal 3y plus 7. So we're going to confirm that. I'm going to do 3 times 7 minus 14 and 3 times 7 plus 7. That gives me 42 minus 14, and that gives me 21 plus 7. And I get 28 equals 28. So this verifies that my opposite sides are congruent. I got 28 for both sides. And now I need to compare the other sides. So 3x plus 7 should equal 8x minus 9. And this time we're using 3.2. So 3 times 3.2 plus 7 should equal 8 times 3.2 minus 9. So 3 times 3.2 is 9.6 plus 7, and 8 times 3.2 is 25.6 minus 9, and I get 16.6 and 16.6. They do verify and match. So I am showing the work to verify that these are parallelograms because they do equal each other. Okay, find the values of A and B that would make the quadrilateral parallelogram. Okay, so now instead of giving us and verifying that those values create the parallelogram, we have to give it. So, just like in the last example with the sides, I know that my sides should be congruent. So 2a plus 6 should equal 3a minus 10. Now, from this point, from here, I'm just going to solve for a. So I'm going to move 2a to the other side, so I get 6 is equal to a minus 10. And now I'm going to move 10 to the other side, and I get 16 is equal to a. So a equal to 16 should give me would make this a parallelogram. Now I have 5a plus 1 should equal 6b minus 3. Well, I already know what a is. It's 16. So I'm going to substitute that one in. Plus 1 equals 6b minus 3. And 5 times 16 is 80. 80 plus 1 gives me 6b minus 3, and 80 plus 1 is 81, equals 6b minus 3. Then I'm going to add 3 to both sides, so that gives me 84 equals 6b, and dividing by 6 gives me 14 is equal to b. All right, so for number 11, I have 16 and 14. Those are the numbers for A and B that would make it a parallelogram. Okay, number 13. This time we have the diagonals, and we know the diagonals bisect each other. So that means that the pieces should be equal to each other. So if I have 5b minus 7, I know that should equal 3b plus 6. Now I just need to solve for b. So I'm going to take 3b and move it over, so I get 2b minus 7 equals 6, and I'm going to take 7 and move it over, and I get 2b is equal to 13. And when I divide by 2, b is going to equal 6.5. Now for the other diagonal, I have 3b minus 5 should equal 2a. Well, I already found b. b is 6.5. So 3 times 6.5 minus 5 should equal 2a. And that gives me 19.5 minus 5 should equal 2a. And that gives me 14.5 should equal 2a. And divide by 2, and that gives me 7.25. So A would have to be 7.25 when B is 6.5 in order for the diagonals to be congruent. Okay, show that the quadrilateral with the given vertices is a parallelogram. Okay, I'll try and graph these the best I can. W is -5, -2. Okay, so there's that point at W. X is -3, 3. That's X. And 3, 5. And that's Y. And then Z is at 1, 0. All right, so if I try to connect my vertices, they want us to show that it is a parallelogram. Okay, now we have all of these properties available to us, and we have the definition. So one of the ways that I can show you that this is a parallelogram is to actually find the slope and make sure that my opposite sides are parallel. So if I find the slope, I am going up 1, 2, 3, 4, 5 units and to the right 2. Well, in order for these to be parallel, from point Z to Y, it has to go up 5 and to the right 2. So 1, 2, 3, 4, 5. It does go up 5. It does go to the right 2. So I know that these two sides are parallel. And then I can do the same thing with the top side and the bottom side. So going from Z to Y, or X to Y, I'm going up to the right 1, 2, 3, 4, 5, 6. So up to the right 6. And then from W to Z, I need to check and see if it goes up to the right 6, and it goes up 2 to the right 1, 2, 3, 4, 5, 6. So yes, they both have the same slope, which means these two lines are parallel. And my answer is yes, because I've proven opposite sides are parallel. Okay, number 17. Let me clear my board. Okay, number 17, J is at -1, 0. So there's J. -3, 7. There's K. 2, 6. There's L, and M is at 4, -1. Okay, if I try to connect my vertices. Okay, so if I'm trying to prove this is a parallelogram, we've got all those properties. We can test those too. However, I'm just going to go by the definition that the opposite sides are parallel because I can find the slope of my points. So I'm going to check the slope of each of my lines. So on K, I'm starting at 7 and I've got to go down to 0. So I'm going down 7 and I've got to go to the right 2. So I'm going to check from L to M if I'm going down 7. 1, 2, 3, 4, 5, 6, 7, and to the right 2, and I am. So that tells me that these two lines are parallel. And so I'm going to draw my triangle. Let's see, I have to go up 1 and to the left 5, and to the left is negative. So I need to check from J to M. I go up 1 and to the left 1, 2, 3, 4, 5. Okay, so I do see that they both have the same slope, which means those are also parallel. So yes, these are also parallelogram because the opposite sides are parallel. All right, good luck.